Hey everyone, welcome back to the channel, where we uncover the most fascinating developments shaping the future of aviation and air mobility. Today, we are exploring several remarkable electric vertical takeoff and landing aircraft that are redefining how people could travel in the years ahead. These eVTOLs aim to make air travel quieter, cleaner, and far more convenient, potentially transforming transportation across cities and regions. So, let us begin with one of the most compelling designs currently in development. Let us start with an aircraft that is attracting serious attention in the eVTOL industry because it combines an intelligent engineering strategy with technologies that could make air taxis genuinely practical for everyday operations. The Overair Butterfly is an all-electric, piloted eVTOL air taxi being developed by Overair in the United States, drawing on decades of aerospace experience that traces back to Karam aircraft. Its main goal is to combine efficiency, low noise, performance, and dependable real-world operation in a package that addresses several weaknesses found in competing concepts. At the center of the Butterfly is its optimum speed tilt rotor system, combined with individual blade control technology and four large, slow-turning rotors powered by several electric motors. The system can continuously optimize rotor performance throughout different stages of flight, producing strong vertical lift before transitioning smoothly into efficient forward movement. The large rotors are particularly important because their slower rotation can reduce energy consumption during the demanding hover phase by as much as 60% compared with smaller propeller configurations, while also helping bring noise toward an impressive target of approximately 55 decibels. That could make the aircraft considerably more suitable for populated urban environments. Its lightweight carbon fiber composite structure, high wing, vertical stabilizer, and retractable wheeled landing gear are designed to provide stable cruise characteristics and straightforward ground operations without adding unnecessary mechanical complexity. That approach could help reduce maintenance requirements and increase aircraft availability over time. However, commercial pricing remains undisclosed because the aircraft is still under development, with Overair targeting certification around 2027. Safety is another major part of the design, with redundant propulsion architecture and individual blade control technology helping reduce vibration, improve passenger comfort, and limit mechanical stress over extended operation. These characteristics could provide an advantage in a market where competing eVTOL concepts continue to wrestle with high energy consumption, excessive noise, and complicated flight transitions. In terms of performance, the Butterfly is designed to carry one pilot, as many as 5 passengers, and luggage, while reaching a cruise speed of roughly 180 miles per hour, a maximum speed close to 200 miles per hour, and more than 100 miles of range from a single charge. Because it produces no direct emissions during flight, the aircraft could become a strong candidate for cleaner urban and regional transportation without relying on conventional runways. Naturally, battery limitations and regulatory certification remain significant obstacles, but Overair benefits from its military aerospace background and support from major partners such as Hanwha, giving the project substantial credibility as development continues. Next, we have an aircraft that offers a completely different vision of personal air mobility and demonstrates just how versatile vertical flight could become in the coming era. That aircraft is the Alto Volo Sigma, an advanced hybrid electric eVTOL being developed by the London-based aerospace startup Alto Volo in the United Kingdom. Its biggest advantage comes from combining two different propulsion concepts in a carefully integrated package. Electric motors provide the immediate response, quiet operation, and clean power needed for vertical takeoffs and landings, while a liquid fuel system supplies greater energy density for efficient longer-distance cruising. This combination allows the Sigma to travel substantially farther than many fully electric aircraft while maintaining operating costs that could remain practical for a high-performance personal aircraft. During urban operations, its electric propulsion system is designed to produce approximately 80% less noise than conventional helicopters, making it better suited to residential locations, rooftops, and compact landing areas where excessive noise could be a serious concern. Once longer distance travel begins, the aircraft can shift into hybrid operation, allowing its fuel-powered generator to support extended flight. The centerpiece of the concept is its hybrid electric tilting jet propulsion system, which is designed to create a smooth transition between hovering and fast-forward flight while maximizing efficiency. According to its performance targets, the Sigma could deliver approximately twice the fuel efficiency of a conventional helicopter while achieving about 1.5 times the cruise speed. Its projected cruise velocity is around 220 miles per hour, while estimated range reaches approximately 510 miles in hybrid operation or about 260 miles using electric power alone. Those figures could make the aircraft attractive for regional point-to-point travel, weekend journeys, and business trips where avoiding airports and ground traffic could save considerable time. Safety is also built into the concept through redundant flight controls, multiple independent motors, and a ballistic parachute system intended to provide an additional layer of protection during emergencies. Its lightweight but durable construction is likewise intended to support frequent operation while limiting maintenance demands compared with more complicated aircraft. For private owners, the Sigma could therefore offer an unusually flexible combination of speed, range, low noise, and modern cabin comfort, delivering a more practical form of personal aviation without being restricted by the short range associated with many battery-only aircraft. However, the project still faces challenges common to emerging eVTOL programs, including the substantial investment associated with hybrid propulsion and the regulatory requirements surrounding personal aircraft certification and operation. Even so, its combination of extended range, impressive speed, and everyday usability could make the Alto Volo Sigma an especially intriguing option for people ready to experience the next generation of personal flight. Another serious competitor gaining attention in the eVTOL industry is the vertical aerospace Valo, previously called the VX4, developed by the innovative team at Vertical Aerospace in the United Kingdom. This piloted urban air mobility aircraft represents a more production-oriented evolution intended to turn short city and regional flights into a practical and potentially affordable transportation option for both operators and passengers. One of its defining features is the arrangement of 8 electric propellers positioned across the wings and tail, generating strong vertical lift for takeoffs from small vertiports and rooftop facilities before transitioning efficiently into wing-borne cruise flight. Because propulsion is entirely electric, the Valo produces no direct emissions and is designed to operate at very low noise levels, making it particularly attractive for densely populated areas where conventional helicopters can be disruptive. Its carbon composite airframe, advanced flight control systems, and extensive redundancy are designed around demanding airliner-level safety requirements, giving passengers and operators greater confidence as the aircraft moves towards certification. The distributed electric propulsion architecture also avoids much of the mechanical complexity associated with traditional rotorcraft and some hybrid designs, potentially reducing maintenance costs, shortening turnaround times, and improving energy efficiency. This combination of simplicity and efficiency could help make urban air mobility more accessible to commercial operators without requiring the massive infrastructure associated with conventional airports. The Valo is targeting a cruise speed of approximately 150 miles per hour and a range of roughly 100 miles, making it well suited to airport transfers, rapid urban connections, and short regional routes where avoiding road congestion could save significant time. Passengers are expected to benefit from a quiet and comfortable cabin, premium interior features, and useful luggage space. Drawing on extensive development experience from the VX4 program, including piloted transition testing, the Valo incorporates improved aerodynamics, a redesigned battery arrangement beneath the cabin floor, and upgraded materials developed alongside major aerospace partners to support efficient production and long-term durability. Its key strengths include strong safety redundancy, quiet zero-emission operation, and the potential for high aircraft utilization without the need for conventional runways. However, battery performance at larger commercial scales and the final stages of regulatory certification remain important obstacles. With certification progress targeting 2028 and substantial industry support behind the program, Vertical Aerospace continues working toward bringing the Valo into commercial operation. For a machine that takes a radically different approach to electric flight, the Cyclotech Blackbird deserves a close look. Developed in Austria by Cyclotech, this all-electric, uncrewed technology demonstrator was created specifically to test and prove the company's highly unconventional cyclorotor propulsion system. 6 electrically powered cycloidal rotors provide thrust vectoring through the full 360-degree range, giving the aircraft an extraordinary ability to direct force almost instantly in virtually any direction. Rather than serving as a passenger aircraft, the Blackbird functions as an airborne research platform for testing advanced propulsion, avionics, autonomous control systems, and next-generation flight software in real, operating environments. Its lightweight carbon fiber composite airframe and straightforward fixed skid landing gear keep the demonstrator relatively simple, durable, and inexpensive to modify as engineers refine the technology. The Blackbird completed its first successful flight in March 2026, demonstrating strong vertical lift, controlled hovering, pitch adjustments, airborne braking, and highly accurate landings despite demanding wind conditions. The most fascinating element is the cyclorotor itself, which can rapidly change thrust direction without relying on the conventional tilting mechanisms found on many eVTOL aircraft. This gives the Blackbird exceptional low-speed control, precise positioning, and stability within confined areas, potentially opening new applications ranging from urban logistics and emergency missions to future passenger aircraft. The technology could also improve safety through propulsion redundancy while reducing mechanical stress, noise, and energy consumption during demanding hover and transition operations. Such advantages could eventually translate into lower operating expenses and greater reliability in difficult environments. The Blackbird remains a technology demonstrator, however, and significant engineering work will be required before this propulsion concept can be scaled into larger crewed aircraft and satisfy broader certification requirements. Even so, its unconventional approach demonstrates that future eVTOLs do not necessarily have to rely on familiar propeller and rotor configurations. With successful early flight testing and an ambitious engineering philosophy, the Cyclotech Blackbird could help inspire a new generation of highly agile and precisely controlled electric aircraft while advancing the broader development of flexible air mobility. Meanwhile, China is producing some equally ambitious ideas, including a futuristic land-and-air vehicle prototype from Chery Automobile that combines autonomous driving with electric vertical takeoff and landing capability. This modular flying car presents a bold attempt to merge everyday road transportation with personal aviation into a single integrated mobility system. Its most interesting feature is the modular architecture, consisting of a ground vehicle chassis, an intelligent passenger cockpit, and a separate aircraft module. This arrangement is designed to let users transition between road travel and aerial transportation without the complicated process associated with operating a conventional aircraft, potentially making the concept considerably more accessible than many traditional flying car proposals. Rather than depending on conventional steering wheels and pedals, the prototype uses automated driving technology and intelligent control systems, allowing occupants to rely on the vehicle while it handles both roadway navigation and flight operations. That approach could remove much of the training normally required to operate an aircraft and make personal air mobility more approachable for ordinary users. During flight, 9 electric motors power 8 lift propellers and 1 rear-mounted pusher propeller, while the high-wing configuration, inverted U-shaped tail, and fixed skids contribute to stability and straightforward operation. The result is a system designed primarily for short-distance urban travel, allowing passengers to bypass congested roads and move directly between destinations through the air. Its fully electric propulsion provides zero direct emissions and relatively quiet operation, while the modular architecture could simplify manufacturing, upgrades, and component sharing, potentially reducing long-term costs. The current concept is designed to carry 2 occupants along with luggage and aims for approximately 40 minutes of flight endurance, enough for short metropolitan journeys and nearby suburban connections. Autonomous sensing and obstacle detection could also enhance safety by continuously monitoring the environment and responding to hazards faster than a human operator might. Nevertheless, the project remains at an early prototype stage and faces major challenges involving road-and-air regulatory frameworks, battery endurance, autonomous flight certification, and eventual mass production. Chery's extensive automotive experience, combined with its emphasis on adapting established vehicle technologies, could nevertheless give this unusual flying car a strong foundation as the company works toward turning the concept into a practical transportation solution. On the cargo front, one aircraft focused heavily on practical real-world logistics is the Airgility Atlas, a hybrid electric heavy-lift unmanned aircraft developed by Airgility Corporation in the United States for autonomous, long-distance delivery operations in difficult locations. Its biggest advantage is a carefully engineered hybrid propulsion system that combines 6 large electric rotors for vertical takeoff and landing with a 90-kilowatt multi-fuel turboprop pusher propeller. During cruise, that engine not only provides forward thrust but also replenishes the onboard batteries, allowing the aircraft to maintain endurance without relying entirely on stored electrical energy. The Atlas also uses patented managed auto-rotation technology, which allows the vertical lift rotors to enter an auto-rotating state during forward flight. Combined with its high-wing airframe, this reduces unnecessary energy consumption and gives the aircraft efficiency closer to a conventional fixed-wing platform. The result is lower fuel usage, reduced operating expenses, and greater usefulness in remote regions where roads, airports, or charging infrastructure may be limited. The aircraft can carry approximately 400 to 500 pounds of cargo in an internal payload compartment while cruising at roughly 100 miles per hour. Depending on mission conditions, it can achieve approximately 300 to 600 miles of range and remain airborne for as long as 4.5 hours on a single fuel load. These capabilities make it suitable for urgent logistics missions such as transporting medical equipment into disaster areas, supporting military activities, or moving commercial goods through difficult terrain where conventional transportation may be too slow or expensive. Airgility has also emphasized modularity and operational simplicity, with interchangeable cargo compartments that can reportedly be replaced within minutes. Autonomous flight controls incorporate extensive redundancy, while the rugged airframe is intended for all-weather operation and relatively straightforward maintenance. This combination could help reduce total ownership costs by allowing high aircraft utilization and minimizing complicated servicing requirements. The main advantages are substantial payload capacity, long endurance, and far greater range than most battery-only cargo aircraft, while the hybrid system can still reduce emissions compared with conventional aviation and provide comparatively quiet vertical operations. Certification, manufacturing scale, and commercial deployment remain important challenges, but successful hover testing and continued development indicate that Airgility is positioning the Atlas as a potentially important solution for affordable autonomous cargo transportation in areas where conventional logistics struggle. Another fascinating aircraft is the Volo Region, originally developed by Volocopter and now moving forward under Diamond Aircraft Industries in Germany. This all-electric 4-seat eVTOL is intended to address a part of the market that sits beyond crowded urban centers, connecting suburbs, airports, and nearby regional destinations with faster and cleaner transportation. Its defining feature is a lift-and-cruise architecture that uses 6 vertical lift propellers mounted on twin booms for efficient takeoff and landing, while 2 rear duct fans provide the majority of the forward thrust during cruise. The high-wing configuration and retractable tricycle landing gear further contribute to stable handling and efficient operation throughout the flight. Distributed electric propulsion is paired with fly-by-wire controls, allowing the aircraft to support both conventional piloted operation and autonomous flight, while incorporating multiple redundant systems to satisfy demanding safety requirements. Another particularly useful feature is its battery swapping capability, which is intended to minimize time spent on the ground and allow operators to maintain high daily flight utilization. That could be especially important for commercial fleets where every additional flight can improve economic efficiency. Inside the cabin, large panoramic windows provide passengers with expansive views, while the all-electric powertrain enables extremely quiet, zero-emission operation that could make the aircraft suitable for suburban communities and other noise-sensitive environments. Planned performance includes a cruise speed of approximately 112 miles per hour, a maximum speed close to 155 miles per hour, and a practical range of around 62 miles. Payload capacity is expected to fall between approximately 660 and 880 pounds, giving the Volo region enough capability for short regional connections without depending on conventional runways or lengthy road journeys. Following Volocopter's acquisition and restructuring under Diamond Aircraft in 2025, the program received renewed development momentum, supported by Diamond's manufacturing knowledge and aerospace experience. Continued testing has focused on areas including aerodynamic refinement, battery integration, and overall aircraft efficiency. Its strongest qualities include passenger comfort, rapid turnaround through battery replacement, flexible regional missions, and relatively simple electric propulsion. These characteristics place the Volo region between short-range urban air taxis and larger regional aircraft, potentially creating an attractive niche for high-frequency commuter operations. Battery range remains a significant limitation, but its emphasis on practical regional transportation could make the Volo region an important part of the emerging advanced air mobility network. From the United States comes another fascinating personal aviation concept, the LEO Coupe, a compact electric flying car-style eVTOL being developed by LEO Flight Corporation with space for 2 to 3 occupants. The aircraft is designed to combine the familiarity of everyday transportation with the freedom of personal flight, offering an unusual approach for pilots and aviation enthusiasts who want more flexibility than conventional light aircraft can provide. Its most recognizable feature is the distinctive double box wing configuration, combined with distributed electric propulsion and duct fans that provide both vertical lift and forward thrust. This arrangement is intended to improve stability, reduce aerodynamic drag, and provide additional safety margins while creating responsive handling that could feel more intuitive than traditional aircraft operation. Performance targets are equally ambitious, with a projected cruise speed of nearly 200 miles per hour and an estimated all-electric range between 250 and 300 miles on a single charge. If those targets are achieved, the coupe could support longer personal journeys, weekend travel, and commuting between communities without the severe range restrictions associated with many smaller electric aircraft. Its cabin is designed with large panoramic windows, giving every occupant broad views of the surrounding landscape and making the flying experience more immersive. Semi-autonomous fly-by-wire technology is intended to simplify aircraft control through intuitive interfaces and automated assistance, potentially making the vehicle easier to operate for less experienced pilots. The LEO Coupe is also designed around everyday practicality, with vertical takeoff and landing capability that could allow operation from compact landing areas, including suitable private property, along with foldable wings for more convenient storage on the ground. LEO Flight is also emphasizing streamlined production and reduced maintenance requirements in an effort to make personal electric flight more attainable. Among its major advantages are zero direct emissions, low operating noise, redundant propulsion, and an integrated battery system designed with safety and reliability in mind. Certification is targeted for the late 2020s, while development continues through testing and engineering improvements. The larger goal is to make personal flight feel less like owning a traditional aircraft and more like moving naturally from ground transportation into the air. Battery development, production scaling, and regulatory approval remain substantial hurdles, but LEO Flight's focus on accessibility, practicality, and user-friendly operation makes the coupe an intriguing candidate for the future of personal air mobility. Heading into South Korea, we find another fascinating project from this is engineering. The Shift Kompson, an autonomous, fully electric passenger eVTOL designed for urban transportation and medium-distance regional travel. With no onboard pilot, the aircraft is designed to carry 2 passengers along with their luggage inside a lightweight carbon fiber cabin surrounded by expansive wraparound windows. This arrangement creates an open, bright interior while giving passengers impressive panoramic views throughout the journey. What makes the Shift Kompson particularly interesting is its distributed propulsion system, using 16 electric motors and propellers positioned along wing-supported booms to generate strong vertical lift for compact takeoff areas before transitioning into efficient forward flight. The aircraft is targeting a cruise speed of approximately 168 miles per hour and a practical range of around 137 miles from a single charge, creating a combination of speed and usable range that could work well for everyday urban and regional routes. Its all-electric architecture also has the potential to simplify maintenance and reduce energy expenses compared with conventional aircraft or more complicated hybrid systems. While a relatively straightforward propulsion layout could help manufacturers scale production more efficiently and eventually reduce operating costs for commercial fleets and private customers. Safety is a central part of the concept, with sensors providing comprehensive obstacle detection, redundant propulsion and flight control systems, and advanced autonomous computers continuously analyzing the aircraft and its surroundings. These technologies are intended to maintain dependable operation in crowded airspace and changing weather conditions while reducing risks associated with early-generation eVTOL systems. Among its biggest advantages are exceptionally quiet flight, zero direct emissions, rapid point-to-point transportation, and a comfortable cabin designed around a stable passenger experience. The boom-mounted propulsion system is another distinct development, helping combine the lifting characteristics of multiple rotors with the efficiency required for faster forward travel. Autonomous navigation also removes the need for passengers to have traditional pilot training, potentially making aerial transportation far more accessible. However, the Schiff-Compson remains a developing aircraft and still needs to progress through prototype testing and regulatory certification. Battery limitations will also continue to influence longer-distance operations. Even with those challenges, its combination of autonomous technology, practical performance, lower operating complexity, and urban-friendly design makes the Schiff-Compson an intriguing candidate for expanding accessible air mobility across major cities and surrounding regions. To close our journey through the rapidly evolving eVTOL landscape, we turn to the Klisarov design Acro, an unconventional ultralight recreational aircraft concept created by a design studio in France. Rather than targeting mass transportation or commercial air taxi operations, the Acro focuses on the pure excitement of personal electric flight, particularly for adventurous users who want to explore coastal environments from luxury yachts. Its appeal comes from combining advanced propulsion technology with a deliberately simple and lightweight structure, creating a recreational aircraft intended to deliver an exciting flying experience without the cost, size, and complexity associated with larger eVTOL programs. At the center of the concept is a 6-rotor cycloidal propulsion system capable of providing 360-degree thrust vectoring, giving the aircraft highly responsive control and the ability to direct thrust in virtually any direction. AI assistance is designed to make handling more intuitive, allowing the pilot to perform quick hovering movements, agile turns, and aerobatic maneuvers even when operating in challenging coastal winds. The open cockpit provides an unobstructed connection with the surrounding environment, giving riders wide views of the ocean and creating a more immersive experience than a conventional enclosed aircraft. Its three-dimensional printed airframe is intended to reduce overall weight while maintaining a simple construction approach, making the aircraft easier to store aboard yachts and potentially less demanding to maintain than more elaborate carbon fiber designs. Lightweight construction also reduces the amount of power required during flight, while redundant propulsion gives the aircraft additional resilience if one motor or rotor experiences a failure. An emergency parachute adds another layer of protection for recreational operations over water. The Acro also offers several appealing environmental advantages, including quiet electric propulsion and zero direct emissions, which are especially appropriate for peaceful marine settings. Its highly maneuverable design could allow owners to explore secluded coastal locations, fly short recreational routes, or simply experience personal flight as an activity rather than using the aircraft strictly as transportation. As an early-stage concept, however, it still faces questions surrounding production, certification, and compliance with applicable ultralight regulations. Its relatively uncomplicated construction could nevertheless help keep eventual costs more approachable for private owners instead of limiting the technology to commercial operators. With an estimated maximum speed of approximately 63 miles per hour and enough payload capacity for one pilot and essential equipment, the Acro is designed around short recreational flights rather than long-distance travel. Its cycloidal propulsion can improve control and reduce wasted energy during hovering and low-speed movement. while the lightweight airframe keeps overall power requirements manageable. Together, these characteristics create an unusual but compelling electric aircraft that focuses less on transportation efficiency and more on the excitement and freedom of flying. And there you have it, a closer look at some of the most fascinating eVTOL concepts helping shape the next generation of aviation. We have explored everything from practical urban air taxis and hybrid aircraft to autonomous cargo platforms and lightweight personal flying machines designed purely for adventure. The industry is developing at an incredible pace, and many of these concepts could eventually change how people travel through cities, across regions, and even around remote environments. Which aircraft impressed you the most, and what do you believe personal and urban flight will look like in the future? Share your thoughts in the comments. And if you enjoyed this deep dive, remember to like the video, subscribe to the channel, and turn on notifications so you do not miss our next exploration of emerging aviation technology. Thanks for watching, and I will see you in the next one. Safe travels.